Hello and welcome to Tic-Tac-Tour. Today we're learning about how to determine the max or min given standard form of the equation for a quadratic function or a parabola. I've given the equation in two forms just in case you are not yet used to or haven't learned about function notation, which is f of x. Then you can take a look at it in terms of y equals. It really doesn't change or take away from the explanation at all. Okay, so I titled this generally as using the x-intercepts here because technically you could find the x-intercepts using the quadratic formula or by factoring. So in this case, I've created an example that is fairly simple to factor. So we're gonna go that according to that route. But if you'd like, you could also do the same method and instead using the quadratic formula, find your x-intercepts, and then follow through the rest of the process that I'm going to show right now, and you would still get to the same answer. Okay, so let's get started on factoring. We're first going to common factor and take a look at what would be the greatest common factor of -2, +12, and +32. It would be -2. I generally find that if the x squared term is negative, it's best to factor out the -1 factor as well. So just factor out the -2 altogether because it makes it easier to deal with afterwards when you're factoring the trinomial that's left over behind. When we factor out the -2, we get 12 divided by 2 is -6, and 32 divided by -2 is -16. So now what we need to do is we need to find two numbers that would add to equal to the middle term. So -6 and multiply to equal to -16. In order to do this, if you're ever stuck, then I would suggest going through the list of numbers that multiply to equal to -16, or just 16 to get started. Here, let's generalize this a little bit. And so we have 1 and 16, 2 and 8, 4 and 4, and then now introducing the negative again, which pair would equal to -16? Well, you'd have to have one of the numbers be negative, and then because our middle term here, -6, is also negative, we would need to have the larger number be negative. So let's take a look. 1 plus or minus 16 would not equal to -6, so that won't work. 4 plus or minus 4 would not equal to -6, but for -8 and +2, that would work. So we have -8 times +2 gives us -16, and -8 plus 2 equals -6. So those two values work. We'll put them into our equation. And now we have reached factored form of our function equation. So from this, we are going to take out our x-intercept values, which are the opposite of the value that we have inside. But to be more precise and clear about why this works the way it does, when we take a look at the x-intercept on a graph of a quadratic function, so in this case, our function opens down because the a value is negative and it has two x-intercepts. So I'm going to roughly draw it here. Something like that. At the x-intercept value itself, we have the y value must always be 0. And then we're looking for whatever our x value would be here. And then similar idea for the other x-intercept. The y value is always 0. And that's the key thing here that we're going to focus in on. So we're going to say 0 here. And in order for the y to equal to 0 and like for the left side and right side of the equation to be equal to each other, we would need to find what x value would work for that. And if we set each factor of our equation equal to 0, then we would be able to solve for what x value results in the right side being 0 overall and then equaling to the left side. So in this case, when we isolate, we get x equals 8. In this case, it's x equals -2. And the reason why I'm showing this is because sometimes the factors aren't as easy as x minus 8 and x plus 2. Sometimes the x has a coefficient. So if that's the case, then you just take the whole factor, set it equal to 0, and set up your equation, and then solve for x, and you can find what the x-intercept value is precisely. Because also sometimes it turns out to be a fraction that isn't a really nice decimal. So it's just helpful to know why things work the way they do. Now that we have our x-intercepts, we can modify our sketch over here. So we can introduce the coordinates over here that we have 8, 0, and -2, 0 as the x-intercepts. And the reason why it's now helpful to have the sketch on the side is that it will help us visualize what we're doing algebraically. Using the x-intercepts, I'm going to now find what's called the axis of symmetry, which is basically the mirror line that goes down the middle of a parabola. Because parabolas are symmetric in nature, on either side of the axis of symmetry, we should see a mirror image of the parabola. And that is found right in the middle of the two x-intercepts. So we are going to take the average of our x-intercept values by doing 8 plus -2. So you add them up and you divide by 2 because you have two values. So the axis of symmetry is 8 minus 2, which is 6, divided by 2. And we have x equals 3. We write the axis of symmetry as an equation because it represents a line, a vertical line. And in this case, it turns out to be at x equals 3. So this is x equals 3 here. Why is that useful? Well, that also happens to be the x value of our vertex over here. Now all that needs to be found is the y value of the vertex if we want to figure out the vertex itself or the max or min value overall. So in order to find that, we can just go back to our function equation that we had originally and substitute the x value in. And it's okay if we do that in the original equation over here. Or we could also use our factored form of the equation. It's really up to you. It won't make a difference at the end of the day. It's just according to personal preference. So I'm going to go ahead and substitute into the factored form of the equation. And I'm going to show this using function notation. But again, if you're not sure or haven't learned about function notation yet, that's okay. Just understand that we are substituting the 3 in place of x, and we're solving for y. Okay, so we took this form of the equation over here, and we substituted the x value of 3 into the equation, and now we are going to simplify using BEDMAS. So we have negative 3 minus 8, which is negative 11, and negative 3 plus 2. Oh, I'm sorry. I made a mistake. Let's erase. I'm not sure why I put negative 3 in here. Let's try that again. Okay, so 3 minus 8 is negative 5, and 3 plus 2 is positive 5. So we have negative 2 and negative 25, and when we multiply, we get positive 50. So the vertex in this case then is 350. We already had the x value from earlier, and now we found the y value, and we can also state that the max value of the function is 50. In case you're curious about any other methods of finding the vertex given an equation for a quadratic function in standard form, you can also take a look at my other video, which discusses how to complete the square to find the vertex form of the equation. Thank you for watching. Hope this helped.